Welcome, everyone. We'll begin in just a few moments. We're going to give everyone another 30 seconds to a minute to just get connected and make sure everyone's here before we get started. All right. Well, let's go ahead and get started. Welcome to the Trends in Sustainable Cold Storage Design webinar. We are happy to have you all here with us today. For this webinar, chat will be disabled, but the Q&A will be active. We'll respond as we are able to during the webinar, but we'll answer all questions in a follow-up email to all participants after the event, including the responses that we are able to give live. If you provided your AIA number when you registered, we will submit your name and number to AIA so that you will receive credit. If not, everyone who remains on the call for the entirety of the presentation will receive a certificate of completion if you need to self-report. Here's the course description and the learning objectives. I won't read these to you, but essentially what we're going to talk about today is how this rapidly evolving cold chain and cold storage market continues to change and evolve to meet the latest market trends, updates to refrigerant regulations, refrigeration system design choices and sustainability, as well as system types. So once again, welcome. We're happy to have you with us this afternoon. My name is Jen Jewers-Bolin, and I am a principal and lead program manager at Henderson Engineers. I was Henderson's first refrigeration hire back in 2007 and have worked in the refrigeration, grocery, and cold storage arenas for my entire 16-year plus career. I've worked closely with a variety of clients, including 4 of the largest 8 retailers in the US and 3 of the top 7 grocers in the country. My project experience ranges from smaller remodels of a few thousand square feet to large warehouse projects of up to 1.2 million square feet. I also lead a team at Henderson that does mechanical, electrical, plumbing, and refrigeration design for grocery stores, fulfillment centers, and distribution centers, working on both new and remodel and retrofit designs. Dustin Paget is my co-presenter today, so I'm going to turn it over to him so he can introduce himself.
Thanks, Jen. Hi, all. I'm Dustin Paget. I'm the Refrigeration Technical Director here at Henderson. I started here in 2008, and like Jen, I've spent my career here at Henderson in refrigeration design. So I started out in grocery and supermarket design and have expanded into cold storage and fulfillment designs in the more recent years as the industry has been seeing growth in those areas. Now I help lead the refrigeration engineering department, and part of that role is to continually keep a pulse on trends in the refrigeration industry. So things like standards, regulations, codes, and even the equipment supply chain. And then I'll take that, convert it over, and help keep our clients up to date with how all of this affects their facilities, and then in turn, our refrigeration design and engineering. I'm glad you're all here today, and I look forward to sharing the latest trends around these topics with you today. Jen?
Thanks, Dustin. So a quick agenda, we recognize that we have a variety of participants on this call and that you each have unique needs. We'll talk at a high level on some of these factors, as well as do a bit of a deeper dive on some of the other factors, but we're happy to address each participant's unique needs in depth after the call. Contact information for Dustin and me will be located on the last slide, and we'd love to further the conversation with anyone interested. So today we'll go over some of the basics of refrigeration, refrigerant regulations, sustainability, fulfillment centers, as well as system types. So as we get started, let's do a quick discussion around the why. Cold storage is quickly evolving. As trends shift from in-store purchasing to online purchasing, as consumers seek out more fresh and frozen foods, the demand for cold storage warehousing and distribution will continue to increase. Even before the pandemic, the cold storage landscape was rapidly evolving. E-commerce has been on the rise. There's an increase in frozen food demand driven by health conscious consumers, and facility requirements are changing. The average US cold storage facility ranges from 37 to 42 years old. And then COVID accelerated all of this and added in consumer changes. There were changes in behavior early on in the pandemic that caused panic buying, accelerating these trends. Online grocery spending surged 133% in 2020, which I'm guessing comes as no surprise to anyone. A 2020 study by grocery e-commerce specialist Mercatus and research firm Incisive found the growth rate of online grocery retail is expected to comprise 21.5% of all grocery sales by the year 2025. This represents a more than 60% increase compared to pre-pandemic projections. We've seen that online ordering and pickup, or online ordering and delivery, is a new normal. Consumers have expectations for quick shipping, including that same day and next day delivery. The rapid and continued rise in the use of delivery and buy online, pickup in store, or curbside services has stressed store infrastructures. Climate change is also a driver. It's estimated that 40% of all food requires refrigeration. 15% of the electricity consumed worldwide is used for refrigeration equipment. And refrigeration equipment in supermarkets in the US uses anywhere from 35 to 50% of the total energy consumed in that supermarket. There are also synthetic refrigerants like hydrofluorocarbons or HFCs that can deplete the ozone, causing environmental damage. HFCs are the group of industrial chemicals primarily used for air conditioning and refrigeration, and many of these HFCs are short-lived climate pollutants. To combat climate change, some companies have made the switch to natural refrigerants like carbon dioxide, propane, or ammonia. We're likely to see a boost in sustainable options continue over the next few years as environmental concerns become more prominent. We've also seen that 72% of food retailers now have quantifiable goals for energy use reduction. Whether a given retailer does or does not have such targets, regulatory and public pressure on supermarkets to address sustainability is likely only to increase. So getting out in front of the conversation by demonstrating a commitment to meeting specific sustainability targets is valuable from both a cost savings and branding perspective. Everyone from the end consumer to institutional investors to the companies themselves are driving the sustainability train, and this goes up and down the supply chain. So now I'm going to turn it over to Dustin to dive in and go over the basics of refrigeration.
Thanks, Jen. Yeah, so this is absolutely something I'm passionate about and honestly spend most of my day-to-day in the details of refrigeration design. And we could spend an entire hour around this, and we actually do in a different presentation we do for Lunch and Learns. So for today, I'll try and keep it at a higher level to help orient us around the discussion topics we'll touch on today. And as Jen mentioned, I recognize there's a broad spectrum of attendees, so I'll try and keep it short and sweet. All right, so refrigeration systems. Just like the air conditioning at your house or in your car, there are some basic components. There's an evaporator in the space you want to keep cool. In my house, it's in the utility room in line with my furnace. This is where thermal energy is absorbed into the refrigerant flowing through the pipes and components. A compressor and condenser are typically located outside in a condensing unit. And this is where that same heat that was absorbed into the refrigerant is then rejected to the outdoors. And the refrigerant just continually cycles through this system anytime cooling is needed. For larger commercial and industrial refrigeration systems, they really do contain those same basic components, just used in different or larger applications. Now, several of these components use energy, such as the compressors and the fans at the condenser and evaporator. And this system is also charged with a specific refrigerant or refrigerant blends that allows all of these components to be connected by piping. So the areas we'll focus on today are the energy and the refrigerants being used, along with the different facility types being served by these various refrigeration systems. So when it comes to the refrigerants themselves, there are several discussion topics. Today, I'd like to start with the latest updates in refrigerant regulations. So without going into the full history of regulations, just to set a foundation, I like to provide a brief timeline and a quick snapshot of the current regulatory changes. So these are ever evolving, but there's some hope that here in the near future, things are going to start to level out. All right, so going back to the 80s. So in the 80s, we found that the refrigerants being used were depleting the ozone. And through efforts such as the Montreal Protocol in 87, there was a move away from those conventional refrigerants that had been used for the previous century. In the US specifically, the EPA created boundary and phase out requirements that are still followed today. And then more recently, the refrigerants that replace these ozone depleting substances have been found to be greenhouse gases contributing to climate change. And as a result, there's yet another migration away from the current refrigerants. This is on a global scale through things like the Kigali Amendment and Paris Agreement, and now in the US through recent legislation to reduce HFCs nationally. In fact, as recent as December 2020, as part of the COVID relief bill, there's some timing and extra regulations nationally for HFC phase out. And that's for the whole US. Now, looking at specific states like California, they've already taken more drastic steps in transitioning to more environmentally friendly refrigerants. So currently, any new systems are to meet more stringent regulations, along with existing system retrofits under certain conditions as well. There are even mandates to reduce the current HFCs in existing facilities. So those with operations in these areas must be proactively making strides toward reductions. One of those goals is to reduce greenhouse gas emissions by 40% by the year 2030. So for someone operating several sites in California, maybe changing a handful of existing sites to CO2 systems as they reach end of life. Then by taking a weighted average of all of those sites, this would help meet that compliance goal of with that coming deadline. Now, with all the different rules, depending on facility location, this can kind of make it tricky when operating multiple sites across different locations. But if you have questions, just know we're keeping track of all of this and even working with interested parties in bringing some level of consistency where it makes sense. Now, turning away from regulation. So regulations can be somewhat reactionary, but proactively, Henderson and many of our clients we work with have already established sustainability goals. So under this topic of sustainability, I'd like to just kind of use Henderson's goals as a framework, but note these goals really do align with a lot of our clients' goals that have been established already. So from a big picture perspective, our aim is to establish a regenerative design framework within our industry to bring solutions that restore, renew, and replenish sources of energy and materials while benefiting clients, communities, and ecological systems. Net zero, that's kind of the blanket umbrella that we're looking at here. So specifically here, we're looking at embodied carbon and operational carbon. So that embodied carbon is the materials used in construction, while operational carbon is anything the building needs after construction. So things like energy, replacement refrigerant, and then equipment over the life of the building, whether it needs to be replaced or through maintenance and repair. Now, refrigerant, it does kind of fall within both embodied and operational because it is installed initially and then does need continual maintenance. Now, electrify everything, eliminating fossil fuel-based systems from all building designs, and then future-proofing all designs to allow for future full building electrification. So that big trend is building electrification and supply of clean energy. Now, I'd like to put a refrigeration lens on that for a moment. Grocery refrigeration systems, let's talk about that. Here's some stats. Jen already mentioned this, but in a grocery store, roughly 40% of the annual energy used by that store is used for the refrigeration system. So we can totally look for opportunities to reduce energy. So things like adding doors to the open refrigerated cases on the sales floor, looking for ways to mitigate infiltration into the walk-in coolers and freezers back in the stockroom, things like that. But another path that I want to focus on is the carbon reduction of the refrigerant itself within the system. So as I mentioned before, this part of the system is critical when looking at carbon reduction. Now, the EPA recently reduced the acceptable refrigerant leak rate for commercial refrigeration systems. It was 35%, now the acceptable rate is 20% on an annual basis. That still sounds like a lot, right? A recent study indicated that the average annual leak rate of a supermarket or grocery system to be well above that threshold. Not only that, older refrigerants can be up to 4,000 times more harmful to the environment than natural refrigerants are. So put another way, every pound of old refrigerant leaked to the atmosphere does 4,000 times more damage than a single pound of CO2. CO2 is the baseline refrigerant that all others are compared to. So for grocery or warehouse systems alone, we're talking thousands of pounds of harmful refrigerant at every site in the US. That's pretty alarming. It's also worth mentioning that leaky systems have poorer performance, so they consume even more energy. So even if the energy consumption of all these systems is able to be offset by supply of clean energy, there is still that large potential of leaking harmful substances to the atmosphere. All right, what are we going to do about it? As an industry, we're focused on refrigerant types, specifically lower GWP refrigerants. The term GWP is essentially the measure of global warming potential of a given pound of refrigerant, again, compared to a pound of CO2, were it to leak into the atmosphere. There are solutions at hand. So for now, moving away from those HFCs, there are some interim refrigerants called HFOs. They are still slightly flammable, but when mixed with a little traditional HFC, they are almost drop-in replacements. So that means if your goal is to meet regulatory compliance, these refrigerants can be dropped into existing systems without major equipment upgrades. These HFO blends are still above the more stringent GWP threshold that certain parties want to see. So because of this, we're already seeing trends way up for using natural refrigerants like CO2, propane, ammonia. Also, these are natural and virtually unlimited in supply if they need to be captured, reclaimed, cleaned, and then put back into the systems. I will note, though, that natural refrigerants do come with some extra safety precautions just due to those operating at maybe higher pressures or being slightly flammable. So right now we're working with industry partners to ensure that codes and standards are keeping up with the extra demand to move toward more environmentally friendly refrigerants. So not only is the government requiring changes and now corporate sustainability goals are being set, now the general population is even much more aware of the impact refrigeration is having on the environment. So now that those sustainability goals have been established and provided to us and really the rest of the world, that's given us the ability to partner and work towards solutions together. To explain a little bit of this better, let's look at a quick case study. So this is one we did for a large cold storage facility. And really the focus here is mainly on the refrigerant being used and its environmental impact. So this assumes a more current system with a slightly better performance than the average aging systems that are out there. But we're looking at the system with a refrigerant fairly current. It's R407A, and that has a GWP of 2,107. And we're comparing that to an equivalent system using CO2, again, with that GWP baseline of 1. So this chart also shows the relative charge of each refrigerant. Note that under the same design conditions, CO2 is also a more efficient refrigerant and therefore uses fewer pounds per system. This example also uses a more conservative or slower leak rate over 10 years compared to the 3 or 4 years shown earlier. So over a given 10-year period, using CO2 is over 2,000 times better from an environmental impact perspective. In this scenario, that's equivalent to taking 671 cars off of the road each year for those same 10 years. Now, we've also run scenarios just like this for other facility types like grocery stores. And I'll note that there are other factors to consider when looking at the bigger picture, and we'll look at that a little bit later. But for now, I just want to move on from refrigerants and shift gears a little bit. Next, we'll take a look at trends we're seeing in the cold chain. And for that, I'll hand it back over to Jen.
Thanks, Dustin. So as Dustin said, we're going to take a quick look at some recent cold chain evolution trends. If we look at the traditional cold chain model, food is delivered from food production and food processing facilities to distribution centers. It'll then go from distribution centers to grocery stores via semi trucks. Shoppers go into the grocery store, they'll select their groceries, pay for them, and then take them home. We previously mentioned that online grocery retail is expected to comprise over 21% of all grocery sales by 2025. This rapid and continued increase in the use of buy online and delivery or buy online and pick up in store or curbside has stressed the existing store infrastructures. So, how do we meet customers' needs and expectations to get fresh groceries quickly in the manner they want? One way to do this is the addition of fulfillment centers to the cold chain. Food is still delivered from food production and food processing facilities to distribution centers, but from the distribution centers, it can go either to grocery stores or to the fulfillment centers. If the food goes from a distribution center to the grocery store, there's still the traditional method of shoppers going into the store to select their groceries, pay for them, and then take them home. Or shoppers can order online, either through the retailer or through a third party site. The retailer or third party vendor will fulfill the order, and the customer can either pick up curbside or in store, or have that order delivered directly to their home. Then, food could also instead go from a distribution center to a fulfillment center. Fulfillment and distribution are two distinct but related segments in the supply chain. Distribution is positioned higher on the chain and deals with the movement of goods at the pallet, unit, or case level. Distribution positions products to then be fulfilled. Fulfillment deals with moving the individual items to the end users. In the fulfillment center model, consumers place orders online. The orders are filled by the retailers at a fulfillment center, and then they're delivered to the consumer. Regardless of whether you're looking at an online or an in-store shopping experience, customers still expect a fresh product. So that cold chain supply has to be efficient to move perishable product quickly, while also meeting expectations of speedy delivery. There isn't necessarily a one-size-fits-all approach. Over the last 2 years, we've worked with our clients on many different parts of the cold chain, from traditional grocery stores to curbside and online grocery pickup remodels to micro-fulfillment centers, last-mile delivery fulfillment centers, and large distribution centers. Some of the fulfillment trends we've seen include dark stores. Dark stores are a traditional grocery store setup that's been converted to a local fulfillment center. It's not open to the public, but only to employees. Store employees will fulfill online orders in the dark store for either pickup or delivery. It mimics a miniature warehouse-like space. Usually there are longer aisles, and then you wouldn't see things that you see in a traditional grocery store, like the salad bar or checkout candy display. Everything is centered around helping the employee fulfill orders quickly versus consumers' individual shopping habits. There's also micro fulfillment center trends. The micro fulfillment centers are typically anywhere between 3,000 and 10,000 square feet. Micro fulfillment centers can be co-located with existing stores, allowing grocers to utilize existing retail space and also save on real estate, or they can be standalone facilities. Micro fulfillment centers help support automated fulfillment for grocery delivery and curbside pickup. They also aim to take the speed of localized in-store pickup and combine it with the efficiency of large automated warehouses. The placement of micro-fulfillment centers within cities or urban areas can substantially reduce the distance between an ordered product and a customer, making the last mile delivery cheaper, quicker, and more sustainable. Another trend we've seen is that of fully automated warehouses. The fully automated warehouses can look and range from options like bots on wheels, conveyors, robotic arms. There's not one size fits all solution, even in that individual space, if you're just looking at the fully automated warehouse. So the recurring theme that we're seeing here on fulfillment trends is that there are a lot of ways to get groceries to the consumer. The different cold chain supply options have different refrigeration needs and requirements. So I'm going to turn it back over to Dustin to tell us about some of them.
Thanks. Right. So now we know about the refrigerants being used in the facilities requiring refrigeration. But the final piece of the puzzle I want to look at, it revolves around the refrigeration system types, like what equipment options are out there and the costs involved. So we're looking at this both for new systems and as well as the existing equipment, maybe upgrades or replacement and maintenance. So Historically, the sort of tried and true refrigeration system seems to have been an outdoor central machinery enclosure, maybe with air-cooled condensers sitting right on top. And a major benefit to this system type is the manufacturer can completely build them at their factory, ship it right to the site, drop it in place, and with a few connections, it's ready to run. And these systems work fairly well for a good majority of applications. For even larger facilities and systems, there are typically central plants located inside the building. But these are not the only option. If we want to look at a variety of facility types with a focus on sustainability, there are some other options. So maybe for those larger facilities, we do stick with that central direct expansion, DX refrigeration system, but use that lower GWP refrigerant or even naturals like CO2 or ammonia. Then you can also use water cooled or water assisted condensing. So this would help with both goals to use less energy and have a smaller environmental impact in the event of a refrigerant leak. Now for urban groceries, maybe micro distributed systems would be a great option. These decentralized smaller units localized at the fixtures contain smaller charge of refrigerant, so also reducing that leak potential affect the environment. And now more than ever, lower GWP versions are more widely available for these systems. Now, when putting in new systems, it may be a good idea too to build in some flexibility for future growth while keeping a lens on energy consumption and the current needs. But utilizing existing systems could be an option as well. One would be by relatively simple refrigerant changes to using lower GWP refrigerants as explained earlier. But another option might be to convert that central plant into a chiller that cools and pumps maybe water or glycol mixture out to those localized smaller systems. Right now, we're working with several manufacturers to ensure those product lines will be widely available to serve this ever-growing need for the variety of system types. And as the demand increases, we've been told by those manufacturers that the first cost could all but match that of the traditional systems. And speaking of cost, we enjoy working with clients to help understand the tipping point for equipment retrofits and upgrades versus a full replacement. Now, there are several factors that weigh into this. One of them is this. So as many of you might be aware, the skilled labor base that has been relied upon for decades is now aging out of the workforce. And so modular design for repeatable, reliable installation and maintenance is something we and the industry are deeply investing. And we're expecting that as a result of that, the labor and material costs for refrigeration systems may actually decrease. Now, on top of that, there's some other good news. So with all of the new regulations I mentioned earlier that are driving the change for new refrigerants and system types, there are actually currently funding assistance opportunities. So these are rebates and incentives through both government and private entities. This is kind of similar, I think of this like the recent solar panel energy incentives. And I think that about does it for the equipment updates. So I'll hand it back over to Jen to wrap us up.
Thanks, Dustin. So just to go over some of the things we've talked about today, there are a lot of factors to consider when looking at the evolution of the cold chain supply. One of those is refrigerant regulations. Those include the hydrofluorocarbon or HFC phase out and the increase in the natural refrigerant usage. In the US, the HFC phase out was included in the recent COVID relief bill at the end of 2020. But we're also seeing that some states like California have already taken even more drastic steps in phasing to more environmentally friendly natural refrigerants. In California, currently any new systems have to meet these more stringent restrictions, as well as some of the existing system retrofits under certain conditions. There are also sustainability goals and the environmental impact. 72% of food retailers now have those quantifiable goals for energy use reduction. Now that the sustainability goals of the retailers have been established and shared with us and the rest of the world, we all have the ability to work together towards solutions to meet these goals together. We're also seeing that there's no one-size-fits-all approach to fulfillment. Traditional grocery store shopping, online ordering, and either curbside pickup or delivery through the retailer or a third party, or shopping and delivery via traditional grocery stores, dark stores, or micro fulfillment centers are all different approaches to getting the consumer the groceries and the goods they want. Finally, refrigeration system types can reduce the global warming potential, refrigerant charge, and energy use. There are many factors that can be considered when you're choosing your refrigeration system type, and some of those include the type of facility, if it's a new store, or existing equipment upgrades or replacements, the project location from a geographical standpoint, and even urban or rural. And then those will help drive the system type. We're working with several manufacturers to ensure product lines will be widely available to serve this ever growing need for better, safer, flexible, and more optimized systems. I'd like to remind people to go ahead and use the Q&A feature. We've had a couple of questions come in, so we're going to start there, but we'll continue to answer questions as they come in. And if there's any that we're not able to answer or need to provide more information, we'll send those out along with the questions that we were able to answer live during the chat to everyone who attended after the webinar. So Dustin, looks like this first question is for you. Is California the only state with such stringent guidelines? If you're in another state, what do you need to know?
Okay, great question. Simple question, loaded answer. So, as we saw earlier, the EPA actually has governance over those ozone depleting substances. But when we're looking at global warming potential, that isn't governed by the EPA. And so states kind of took it upon themselves to make legislation. California kind of led the pack there. But there are other states that have kind of formed this Green Alliance, and they do have their own regulations. Some of them have been approved. Some of them are sort of in flight right now. But I guess the timelines on those are maybe a little longer than what California does. So that's why I use that as the example, because there is kind of more of an urgent need to make changes for sites in California. I hope that answered the question.
Nope, that was great. Thanks. All right. We have another question on where can I find a list of all government rebates and incentives?
Okay, I can take that one too. So this changes. So again, it's sort of by location, and there are timelines for applications and all of that. So we'd love to partner with you if you have questions specifically for your projects. We can definitely help you navigate that.
So it sounds like the short answer is there isn't a one-stop shop that you can go look and find all of the rebates and incentives, but we can help, and all of any of the people we work with or are coming to us with questions, look for the individual locations, whether it's from a utility, state, or federal rebates. Okay, so the next question is, why does ammonia have a bad reputation?
Interesting. So ammonia is a toxic refrigerant, and so it actually has an impact on human health. We are limited in the type of space use that can be in. So, for instance, you wouldn't want a space that's open to the general public with a large charge of ammonia for safety reasons. But there are several applications. It's from a GWP standpoint, it is natural. It does have a low GWP, and so, or virtually zero. So it does have its uses for sure.
There are also some additional OSHA regulations and requirements around the use of ammonia. But if you're looking at large warehouses, as Dustin mentioned, like that's a good application for that, where you may have a central plant situation. You've got 24/7 on-site maintenance staff as well. So we have a question come in. What do you see as the tipping point in the decision between multiple HFC or HFO systems less than 50 pounds charged versus making the change to CO2? Are we seeing any demand for smaller CO2 systems versus racks?
Yeah, great question. So specifically for California, it depends on if it's a new system versus you're retrofitting or maybe trying to make the decision on changing. So it kind of depends on what has been reported to CARB through that program. Across the board, though, we found that traditionally a central packaged unit or a central custom DX unit was more energy efficient. Now we're seeing upgrades on those smaller systems under 50 pounds of charge. Maybe they now have compressors with variable speeds and that sort of thing for energy sake. So there is definitely a need for smaller CO2 systems. It gets a little tricky with the pressures, right? So maybe there are condensing units now available for medium temp applications, but low temp, the compressor sizing comes into play there. And so we're looking at the demand for that and how quickly we can get that demand filled.
Okay. When is a leak detection system required?
um, there are essentially a machinery room, as dictated by the code, requires leak detection. And so, if it's an equipment room with the compressors and everything in there, or a large amount of refrigerant, also walk-in coolers and freezers sort of go by that. But it depends on a few factors. One is the volume of the space. Another is the refrigerant and the allowable amount of refrigerant that can be dumped into that volume of space. And there are a few other nuances, but it is in the mechanical code and in ASHRAE as well.
Thanks, Dustin. So we mentioned that micro-distributed refrigeration systems carry lower charge volumes and therefore reduced leak impact. What are your impressions if there is a greater leak potential of the additional piping, fittings, junctions, etc.?
Right. Well, actually, from my experience, it's actually a lower leak potential because micro distributed from a concept level, if you're looking at the refrigerated cases, maybe on a sales floor of a grocery store, a lot of times those can come with the case already pre-installed. So you actually get that benefit of the factory installing all of those components, reducing the leak potential due to installation in the field. Now that's not always true. If you have like smaller condensing units, I'd still consider that micro distributed, especially if it's water cooled, that could be field installed. It's still a, a lower leak potential due to the quantity of refrigerant. I think though that the question might also be asking because of the added fittings and joints. I don't think that there are necessarily there's not necessarily a higher risk as compared to a central rack with long runs of piping, plenty of joints and turns and everything as well.
Thanks, Dustin. All right. So, how much money or dollars for energy cost savings does a traditional refrigeration require versus a CO2 system?
So the energy savings of a traditional system versus CO2, specifically the energy savings, totally depends on a few factors. So take that central DX air cooled refrigeration system in any given city. If you drop in a DX CO2 system that's air cooled and that's with the same components and technologies, you may see an energy penalty. However, there are other technologies available now for CO2 specific systems, whether that's booster technologies or other things, other options within the equipment itself. We actually see an energy benefit. So you're getting the benefit of the refrigerant being more friendly to the environment and energy savings for those same pieces of equipment.
Okay, we've got another one on energy here. So, are energy reduction requirements for the store or are they for specific components within the store? If we're looking at, depending on the bounds of the energy balance, there may not be a net energy drop for a facility. For instance, the example was of the open cases could reduce the size of the HVAC for the facility. So it's not always a straightforward answer.
Oh, that's a great question. I think we both could help answer this one. So when you're looking at building envelope, looking at the big picture, honestly, what's the carbon impact, right? So we're looking at energy, we're looking at the leak rate and potential of leaks of the refrigerant itself, but also the equipment selections, right? So if you go water cooled, well, now you've introduced water. And so that's another factor in that calculation. So putting on, let's say, doors to an open case actually helps across the board because it's a reduced load for cooling. The equipment can then be sized smaller, the piping and everything, so therefore the refrigerant charge itself is reduced. Yeah, you don't get the cooling credit. I'm thinking mechanically here. You don't get the cooling credits for an open case when you put doors on it, but traditional HVAC side isn't necessarily sized for full cooling credits anyway. So the equipment sizing would not necessarily be able to be downsized.
I think you touched on it as well. Just so you're looking at when you're looking at energy savings, it's not just mechanical equipment versus refrigeration equipment or electrical equipment. We're looking at the building envelope. Infiltration is a really big deal. So what can we do to mitigate infiltration? Are they, especially if you're looking at a larger warehouse type facility versus a grocery store, can we add air curtains? Can we make sure that we're dehumidifying the space? What are we doing with the potential of adding a cold dock? And how are we moving goods from one part of the facility to the other? So it's really looking at the total picture and then what makes most sense from an overall energy use perspective and the whole building systems operations. All right. Well, that is all of the questions we have for now. Thank you everyone for your time and attendance today. We appreciate the chance to talk with all of you, and we'll be following up with the Q&A in a separate email sent out to all of you. But if you have any questions, please feel free to reach out to Dustin or myself. So thank you and have a wonderful afternoon.